Hello everyone, welcome back to my channel. In today's video, we are diving into a concept that's both powerful and tricky, self-recursive loops in MuleSoft. If you have ever faced scenarios where you need to call the same flow repeatedly until a condition is met, like retrieving large data sets from an API, then you have likely come across this challenge. But did you know that using self-recursive flow reference calls in MuleSoft can lead to some serious issues like Mule critical or stack overflow errors in MuleSoft? In this video, I'll break down what self-recursive loops are, the problems they can cause, and how you can implement them the right way. Let's get started. But before we jump, kindly subscribe to my channel for any new updates. Thank you. So this is a sample application which I've already created in Anypoint Studio, which demonstrates the best way of implementing this recursive pattern. I have created a couple of flows here. This is the first flow that gets invoked with the listener of recursive check endpoint, and it makes a call to this subflow, which will actually invoke a third-party API slash accounts. And this third-party API, I have mocked it in another XML file with slash accounts as a listener, and right now it only prepares a mocked response payload back of a customer information. So as part of this requirement, we'll have to retrieve the accounts or customer information for around 1000, and maybe every time we can only retrieve 100 records. So usual implementation would be set up a counter and invoke this third party flow until the payload is empty. So since we don't know the condition when the payload will be empty, we don't have the definite number of times which we'll have to retry, which we have to call the third party API and make the calls. Hence this is the condition where it will break the loop. This is the condition that breaks the loop. And most of the implementations which I see from the developers I have encountered is they make a call, they make a self call with this flow reference. And what it does, this flow reference will make a call of this flow again. It calls a third party API. This would return some response back, and then we'll check the payload size, increment the counter, and again invoke the third party API flow. So this will continue until the payload is empty. Now, what issues does it return? Do you know that this works every time? Let's test this. Let's test this condition, this scenario how the API, how the application behaves if we are trying to invoke this invoke this flow using the flow reference. So just to give you an idea, I have mocked the response payload in such a way that if the counter, whatever we are incrementing, if it is less than 50, it will still generate the response back. But if it reaches 50, it will return empty payload so that the loop can be breaked. Now let's see how we'll test it and see if we see any issues or not with this approach. This is the most common approach I see developers have implemented in their implementations. Okay, now this has been started. Application is started. Let me test by passing recursive check. This is API call that we are triggering. We'll see what is going to happen. So I'm expanding the logs. These are the logs which are returning the customer data back. I have captured the index as well here to understand at which point the breakage is. So this has been working for 18, 23, 25, 34, 38, but you see after 43, after index 43, we started seeing this too many nested child context error. And what happens because of this? It throws a mule critical error, and this is where the application breaks. Since the response of the third party system can be dynamic, the number of records it contains can be dynamic. We can't have a definite number of size or a counter to follow. That is where we most probably will go with this approach, and this will return in all sort of issues. Now how can we tackle this situation? I have created a sample flow here. Let me just comment this. These are not needed as of now. We will uncomment this usage of VM. So this is something which I haven't seen most of the people have implemented, but this is something which I suggest go with this approach. We just push a message to VM, and there will be a listener for the VM consume, and it will actually invoke this third-party API, and this is where it happens. The third-party API is triggered, and it will return the response back, and this will be looped continuously. So whenever a message is posted, it will come to this while loop. It will come to this flow where we have a VM listener. It will set the counter, it will increment the counter here, and then it will make a call to the third party API flow, which is this one. It will invoke the third party API, and it will check the size, and if the size is not met, then it will publish a message to VM queue, and the message will be listened here again. If you see, we are not calling the same flow again and again. This is where we are leveraging the usage of VM. We can have in memory VM or persistent VM accordingly. Push the message here and listen for the message, process it, and invoke this flow again. Let's see how the application behaves if we do this change. This is the most common implementations which I have seen across some projects. I would already suggest that developers to go with this form of implementing. We are not actually pushing a message to this VM queue. It is like a trigger to this queue stating that pushes sample message to this queue, and this will be triggered. Listener will be triggered to make sure the actual flow will be called from this simulation flow. So let's wait for the application to get started, and then we'll see how the system behaves. Yeah, application is deployed. Now previously we have got this issue, too many nested child contexts. Now we'll see what will happen. Here you go, there is no error and it is successful. We'll also check the logs from the console. 43 is where it has failed previously when we used flow reference calls, and now it has processed successfully and it retrieved all the records from the third party system. This is where it's a good way to implement it in this approach, so that we don't end up with lot of mule critical errors at the end. Mule critical is some error which we can't handle with normal usage of error handler. It is a system related error, so system related errors should never be thrown from the actual implementation. So follow the best practices and implement it in the suggested approach. Thank you.